So now let's see what is the energy in SHM. So when the particle is performing that your to and fro motion, it is associated with your kinetic energy as well as your potential energy. So since it is performing that to and fro motion, so it is having some kinetic energy. And what we know that about the kinetic energies, obviously half mv square. So v is equals to plus or minus omega square root of a square minus y square. Just taking the square of that, so you will get half m omega square root of a square minus y square. Further you can write it down, k is equals to m omega square. So the kinetic energy becomes 1/2 your k, again that is your a square minus y square. So that is the expression for your kinetic energy, so which we will get over here. Now to get the expression for your potential energy, yeah, so to get the expression for the potential energy, so we know that, so just to move the particle or to displace the particle from one position to another position, there is a displacement x, so we have to do some work. So work done is equals to force into displacement. So this one is nothing but obviously minus kx into dx. Since it is a restoring force, then again we can say that, so both of them are opposite to each other. dw is equals to kx dx. So the total work done is integration of that kx dx. So the work done which will save in the form of energy, so it is half kx square. So this work done will save in the form of potential energy, and which is your half kx square. Yeah, so this is how we can write it down, the expression for your potential energy, that is a half kx square over here. So this one also you can write it down. So this is your half k is equals to m omega square, again that is your x square, or either instead of x you can take it as a y also, no issues. Yeah, so the potential energy, you can find the maximum and minimum potential energy for this case also. So where I can say that your x or y is equals to 0, potential is energy is 0 at mean position, and when we take that y is equals to or x is equals to plus or minus a, which is nothing but your extreme position, so in that case the potential energy is maximum for that particular case. So the potential energy is maximum, so where I can write it down, so again this is m omega square a square, so that is your potential energy is maximum. So now we have to find the total energy, which is the addition of your kinetic energy plus potential energy. So the kinetic energy is half m omega square in bracket a square minus y square plus half m omega square y square. So after doing the addition, you will get half m omega square a square, where a is the amplitude, m is the mass of particle which is executing SHM, omega is the angular frequency. So how you will get the graph for this? Now even I can say that the total energy is always constant. So when I'm saying that the total energy which I have got half m omega square a square, the total energy, so the total energy, let's say at extreme position, total energy at extreme position, so the total energy obviously we know that it is potential plus kinetic. Now the potential energy at extreme position, so at extreme position again we can say that your y is equals to a. Yeah, so definitely this kinetic energy becomes 0, so the kinetic energy becomes 0 plus obviously potential energy, I can write it down, that is a half m omega square which is a square. So this is the total energy at extreme, the total energy at mean position, the total energy at mean position. Further I can write it down where y is equals to 0, again that is the same then, which is half m omega square a square. Yeah, and that is nothing but your kinetic. So the total energy is nothing but potential is 0. So this is again half m omega square a square, and at any point y, at any position y, already we have calculated that total energy. So in each case the total energy is always going to be conserved. So that is what we call as a conservation of energy. So the total energy of SHM is always constant. Yeah, so from that you can get the graph for this also. So at mean position the kinetic energy is maximum and the potential energy is 0, but at extreme position plus a and minus a. So you can say that the potential energy goes on increasing but the kinetic energy goes on decreasing, but the total energy at each point is always constant. So that is what about the energy in SHM.